And last but not least, we have another new faculty member to address us tonight, Martina Decker.
Hi, thank you very much for letting me actually take part in these amazing thoughts and introduce you to some of the thoughts that I had. And I do have to say that I had a lot of thoughts, especially since I arrived here, that were fueled by a lot of amazing people that I have met so far here at my time at NJIT. And I'm not only talking about my colleagues here in architecture or in art and design, I'm also including people from all the different sciences and engineering that are actually doing quite fascinating work, and that, of course, influence my thoughts and what I have been doing lately. So I've been lingering on adaptation for a while now. And this amazing example of a squid, how it is actually able to adapt to its environment by changing the color of its skin, like pigment, like it can mimic its surrounding, or it can warn predators, or it can really blend in so well that you don't even see them anymore. And this is really an absolutely amazing ability that animals have developed over millions of years. And they're not only adapting to the environment in order to escape predators, but they're adapting to all the influences that are around us. So there are, of course, temperature changes, seasonal changes that are a big part of that. Now, a lot of my work has had to do with the energy and how we use it in buildings. And we can see clearly that in this new graph, the data was released last September, nothing much has changed over the last 5 years, which is a little daunting, especially when we start thinking about what has been happening to our global weather patterns in particular. So you can see here in this video that is recording the temperatures since 1884, what has happened and how it really peaked over the last decade. And we're being presented with a very particular problem that we're all facing now. In particular, the weather events that are basically triggered by this climate change and the rising sea levels are presenting us with an amazing problem, but also a huge opportunity at this point. Now, last semester, we were all hit very hard here on campus and in the entire New Jersey region, in New York as well, by Hurricane Sandy. And there is a new kind of adaptation that we need to think about now. Since 2009, the Task Force for Climate Change Adaptation has been put in place, and they have been issuing all these different strategies over time and different opportunities that we have trying to adjust to these new sets of circumstances that we deal with, not only in our natural environment, but in particular in the built environment. And you can see who the early adopters are and the states that are responding to it first, and you can also see that they're clearly at the coastlines, and they're there for a very good reason. So the task force had established that a lot of the change will actually have to happen on a local level. And this is one of the thoughts that are very true. We all know that out of experience now, that it is going to be a very local issue. How do we adapt to these different sets of circumstances? But I actually want to take this thought a little bit further and actually take it down to the material level. Now, as you know, a lot of my research has to do with how do we actually design materials, how do we influence them so we can make them fit for a new kind of architecture that has the ability to respond to its environment. And when you look at this video, this is an example of how scientists have been able to entice DNA molecules to self-assemble into building blocks that are actually not unlike Lego building blocks, as you can see here. And they self-assemble not only the strands themselves, but the blocks, once they're formed, can assemble into larger structures. Now, these materials can be designed, and we have full control over them, atom by atom, molecule by molecule, and we can give them very specific properties and different porosities. We have quite a tool set by now, and my question is, with this new ability, how do we use it? And I would suggest to think for a second, what do we have in our surroundings? What can we actually use? So when we look at the environment that we build in, some things that we have almost everywhere is actually a thermal input. We have thermal differentials. We have stresses that come from wind or waves. Definitely sunlight, which is one of the most amazing free energy sources that we have. And there is water around, there are different substances. And there are also already a whole range of new materials that can adapt or that have been adapted in order to respond to these different inputs in order to create very specific outputs that we can make use of in the built environment. Now, previously I've always thought about these materials as being used for energy, to address our energy needs. But I actually think we can take this a step further and start thinking about them. How do we actually use them so we react to the impacts that we have created through our energy consumption and our energy addiction and our dependence on fossil fuels? Now, how do we actually work with this? And I think looking at the example of the Darwin finches is actually quite intriguing. They evolved over a very long time span. They had very certain food available to them, and then they adapted to the environment by developing very specific beaks that would allow them to take advantage of the food sources that were in their environment. Now, unfortunately, we do not have the same time span available that the finches had. So we have to really start thinking about how do we actually accelerate that evolution in architecture and in our built environment. And I would say that the only way to solve this problem is actually collaboration. And as architects alone, we cannot do this. We have to work together with engineers, we have to work together with scientists, and we really have to snuggle up to the STEM fields at that point, because together we can actually find some solutions to these very serious problems. So very quickly, just two examples that are promoting a very similar train of thought, but on two different scales. There is a study where Case in New York looked into using multi-junction solar cells, and in order to take advantage of these particular solar cells, they're very high efficient, 44% in laboratory tests, but they're extremely expensive. So what did they do? They started directing and guiding the photons of light, gathering them and channeling them to the solar cell in order to boost the efficiency. Now, scientists have been doing actually exactly the same thing, but on an entirely different scale with a different kind of photovoltaic material. So in this example of a dye-sensitized solar cell, they're using photonic crystals to take the light that didn't pass through the cell and reflect it back to the dye-sensitized layer, the titanium dioxide layer that is married and united with the dye, that will actually enable the material to produce electricity. And there are many, many different scientists from different fields together working with the industry and designers trying to figure out how do we optimize this material so we can take advantage of the transparency and the translucency of this material, and even adjust the color quite accurately to architectural needs. Now, as I said earlier, this is nothing that we can do by ourselves, and we really have to tackle the problems that we're facing in a multifaceted approach in order to make it different. And I think that we are actually perfectly positioned here at the New Jersey Institute of Technology in order to go into this direction. And I hope that we're going to talk about this a little bit more over drinks and during the reception. Thank you very much.
It's amazing to have all these wonderful thoughts go on. It's very frustrating to have you finish in 10 minutes. I want to hear more. So this should be the beginning of many conversations, and I hope collaborations. And I think it's very useful for all of us to see what you are thinking about. I think over a number of years, we'll have the opportunity to hear all of our faculty members present what they're thinking about at this moment. And I think what we're supposed to do at a university, obviously we do research, obviously we teach, but we also think. So the idea that this should be a hotbed of ideas, where students and faculty together work on ideas and live in the realm of ideas, It's a privileged position to be in, and we should take full advantage of it. So I'm really delighted by these 5 talks. I think they are an intellectual feast, or the beginning of an intellectual feast that I hope we will complete over many conversations in the next few months or years. So I think this was a wonderful treat for me, and I thank each of you for agreeing to give tonight's talk. So thank you very much.